Jai Hind everyone, I am Dr. Ekta Pandey from the Department of Applied Science and Humanity, Ajay Kumar Garg Engineering College. Today I am going to deliver a video lecture on the topic Solution of Heat Equation in Two Dimension in Steady State from Module 2 Application of Partial Differential Equation from the course Mathematics 4 KAS 302 or 402. The contents of today's video lecture are two-dimensional heat flow, heat equation in two dimension in its transient state and steady state, Laplace equation and the solution of Laplace equation by method of separation of variable. So let us discuss two-dimensional heat flow. We are going to consider a thin rectangular metal plate of uniform thickness made up of some thermally conductive material with uniform density ρ and uniform specific heat S. So this is our plate and let us keep this plate on XY plane. Okay, then width of the plate is along the x-axis and length of the plate is along the y-axis. Now see, the plate is heated somewhere and then insulated along its top and bottom. Means after giving some initial temperature, the surface of the plate is insulated. So heat will flow along x-axis and y direction only. Heat will flow along x-axis and along y-axis. Means there will be no heat flow in the perpendicular direction of the plate, means no heat flow along the z-axis. So this is known as two-dimensional heat flow. Now let U is the temperature function of the plate at any position xy and at any time t. Then this function can be obtained by solving the partial differential equation given by equation 1. Del u del t is equal to c square del 2u del x2 plus del 2u del y2. This is a partial differential equation. If we solve this equation, then we will obtain the temperature function of the metal plate at any position xy and at any time t. So this is known as heat equation in two dimension in transient state. Now transient state, what is transient state? Transient state means time dependent situation. Here temperature depends on time. So this state is known as transient state. Now think about the steady state where the temperature will be independent of time. So rate of change of temperature with respect to time will be 0. Means you will get del u del t is equal to 0. So equation reduces to equation 2. Del 2u del x2 plus del 2u upon del y2 is equal to 0. And see, this equation is known as heat equation in two dimension in steady state. If we solve this equation, then the solution of this equation will give us a temperature distribution of the metal plate in the steady state. This equation is also known as Laplace equation in two dimension. Because here u depends only on two variables x and y, this is known as Laplace equation in two dimension also. So we can call this equation as heat equation in two dimension in steady state or Laplace equation in two dimension. Next, see, in this video lecture I am not going to derive these two equations. Instead of it, we are going to solve these equations by using method of separation of variable. Now in this lecture I am going to consider the solution of Laplace equation only. So let us see the solution of Laplace equation by method of separation of variable. I hope you all of you are aware of method of separation of variable, and if you don't know, then just follow the step I am going to tell you about the method of separation of variable. Okay, so according to method of separation of variable, to solve a partial differential equation, we assume the solution in terms of product of two functions, where each function depends on only a single variable. Here we are going to solve Laplace equation in which u depends on two variables x and y. So its solution can be assumed as u is equal to x into y, where x depend on x and y depend on y. Now since it is a solution of Laplace equation, so it will satisfy the equation. So the next step is to put u is equal to xy in the equation. So what will we obtain? This one. We have put u is equal to xy. Now see the first term. The first term is the partial derivative with respect to x, and second term is partial derivative with respect to y. So if we differentiate this function with respect to x, then y will remain constant. So it can be taken out from the derivative. And see the second term. Here we have a partial derivative with respect to y only. So the x function will remain constant as it is a function of x only, so it will come out from the derivative, and the resultant of this derivation will be this equation: y del 2x upon del x2 plus x del 2y del y2 is equal to 0. Now see, next step is to separate the variable from this equation. What we have to do? We will try to keep x on one side and y on another side. Okay, so how can we obtain this form? See, we can shift this term to the right hand side, and then by cross multiplication we can keep x in left hand side and y in right hand side, and we will obtain this form. See, this form is a variable separated form. X is in one side and y is the other side. Okay, so here we have a variable separated form. But see, one thing which is very important to note here, this equality will hold only for some constant k. Okay, see why. We will see why this equality will hold only for some constant k. See, here x is a function of x only and y is a function of y only. So, in the left term, since x is a function of x only, so output of this term will be a function of x only, or it may be some constant. Similarly, since y depends only on y, therefore output of this term will be a function of y only or some constant. Now see, due to this equality, if we obtain function of x or function of y as the resultant of left hand term and right hand term, then due to this equality, it will create a relation between x and y, which is not required. Think why? If we have phi x is equal to phi y, then this will create a relation between x and y, but x and y are independent variable. No relation can exist between x and y. So this equality will hold only for some constant k. Now see the next point. Also, we can write these equations in terms of ordinary derivative. No need of partial derivative. Why? See, x depend only on variable x, y depend only on one variable y. So we have no need of partial derivative. We can represent these term or these derivative just by ordinary derivative. So what happened? We have two ordinary differential equation, one for x and one for y. Okay, so what we have obtained? By method of separation of variable, the partial differential equation reduced to two ordinary differential equation, one for x and one for y. These two equations are ordinary differential equations, so it can be solved by some known method. So you must know how to solve ordinary differential equation. Also see, the solution of these ordinary differential equation will depend on the nature of this constant. This constant can be 0, positive or negative. We will consider each case one by one. So let us see the first case when k is equal to 0. See, when k is equal to 0, then each equation will be equal to 0. And we have to solve them one by one. See, the solution of first one, 1 upon x d2x upon dx2 is equal to 0. By cross multiplication, we will obtain d2x dx2 equal to 0. And this can be solved by just 2-time integration. So 1-time integration will provide us dx is equal to c1, constant of integration. Just integrate both sides. Then we will obtain x is equal to c1x plus c2. This is the solution of this equation, and we have obtained the value of x is equal to c1x plus c2. Similarly, we can solve the second equation and we will obtain y is equal to c3y plus c4. Okay, so we have obtained the solution of these two equations and we obtained the value of x and y. But what we have assumed? We have assumed u is equal to x into y. So, the solution will be given by u is equal to xy, u is equal to c1x plus c2 into c3y plus c4. So, this is our first solution corresponding to k is equal to 0. Let us consider the next case. Case 2, when k is positive, say p square. Here, I have taken p square. See why? Just to retain the positivity of the constant. P square is a positive value, so it will always a positive value. So, each equation will be equal to p square now. Now, what we have to do? We have to solve each equation one by one. So, let us see the solution of first one. Here, what I have done? See, by cross multiplication, x can be taken to the right hand side. Now, shift this term to the left hand side. Now, what you can observe here, this is an ordinary differential equation of second order with constant coefficient. And you must know that it can be solved by finding complementary function and particular integral. So, let us have a look on the next step. What I have did here, if we take d upon dx is equal to d, okay, and x in common, then we will obtain this form d square minus p square x is equal to 0. Now, we know that solution of this equation is given by complementary function plus particular integral. Now see, right hand side is equal to 0, so particular integral will be 0 and x will be equal to complementary function. Now, to find the complementary function, what we have to do? We have to find the auxiliary equation. It is very easy to obtain the auxiliary equation. Just put d is equal to m in the operator and equate this operator with 0. Then the auxiliary equation will be m square minus p square is equal to 0. What is the next step? Next step is to find the root of this equation. M square is equal to minus p square. This implies m square will be equal to p square. Just take square root both sides, then we will obtain m is equal to plus minus p. Now see, the roots are real and distinct. Therefore, complementary function will be given by c1 e raised to the power px plus c2 e raised to the power minus px. And also it will be the solution of the differential equation. So, x is equal to c1 e raised to the power px plus c2 e raised to the power minus px as particular integral was 0. Okay. So, let us solve the second equation. The second equation is minus 1 upon y d2y upon dy2 is equal to p square. We will apply the same procedure here. By cross multiplication, we will obtain d2y dy2 is equal to minus yp square. Now, take this term to the left side. Then again, we will obtain a differential equation. You can see it is a differential equation, ordinary differential equation of second order with constant coefficient. So, again we can solve this equation by finding complementary function and particular integral. So, by taking d upon dy is equal to d and y in common, we will obtain this form. Now, since y is equal to complementary function and particular integral, but here since the right hand side is equal to 0, therefore particular integral will be 0 and y will be equal to complementary function. Now to find the complementary function, we have to find auxiliary equation, and you can obtain the auxiliary equation by putting d is equal to m in the operator and equate this operator with 0. Now just find the root of this equation. We will obtain m is equal to plus minus pi. Now since the roots are distinct and imaginary, so complementary function will be given by e raised to the power 0y c3 cos py plus c4 sin py. What about this 0? You know the complex number is in the form a plus minus ib. So here m is equal to, we have m is equal to plus minus pi. So real part is 0 and the coefficient of imaginary part is p. So the complementary function is given by e raised to the power 0y, e raised to the power 0y into c3 cos py plus c4 sin py. But since e raised to the power 0 is equal to 1, so we obtain complementary function as c3 cos py plus c4 sin py. And also it is a solution of the differential equation. Since particular integral is equal to 0, therefore y will be equal to complementary function. So we have obtained the value of y, which is equal to c3 cos py plus c4 sin py. So we have obtained the solution of both of the equation. We have obtained the value of x and y, but what we have assumed u is equal to x into y. So using x and y, we can find the value of u, which is equal to c1 e raised to the power px plus c2 e raised to the power minus px into c3 cos py plus c4 sin py. This is our second solution corresponding to positive value of k. Let us discuss the third case. See, when k is a negative, say p square. If k is negative, then here I am taking minus p square just to retain the value of, just to retain the sign minus, negativity, just to retain the negativity of the constant. Now each equation will be equal to minus p square. Now again we have to solve both of the equation. Let us see the solution of first one. Here again we can take by cross multiply x in the right hand side. Now shift this term to the left side, then we will obtain this type of equation. And again you can observe this is a differential equation of second order with a constant coefficient. Now see, we can solve this equation by finding complementary function and particular integral. So again, taking d upon dx is equal to d and x in common, we will obtain this form. Okay, now the solution is given by complementary function plus particular integral. Again, right hand side is equal to 0, so particular integral will be 0 and x will be equal to complementary function. Now to find complementary function, we will obtain the auxiliary equation. Auxiliary equation will be equal to m square plus p square equal to 0. Now just solve this equation, means find the root of this equation. We will obtain m is equal to plus minus pi. Now see, again the roots are complex, a plus minus ib form. So the complementary function will be given by e raised to the power 0x, which will be equal to 1, into c1 cos px plus c2 sin px. This will be our complementary function and also the value of x, because particular integral is 0. Now similarly, we can solve our second equation. See, here again by cross multiplication we can take minus y to the right hand side and now shift this term to the left hand side. Then this is again ordinary differential equation of second order with constant coefficient. Here what we can do, just take d upon dy is equal to d and y in common, then we will obtain this form. See, we are going to solve this equation by finding complementary function and particular integral, but right side is 0, So again y will be equal to complementary function only. Now to find complementary function, we will find auxiliary equation, and auxiliary equation will be m square minus p square is equal to 0. What we have to do, just put d is equal to m in the operator and equate this operator with 0. Now we will find the root of this equation, then we will obtain m is equal to plus minus p. Here you can see the roots are real and distinct, therefore the complementary function will be given by, see, the complementary function here will be given by C3e raised to the power py plus C4e raised to the power minus py. This is wrong, please note. Here complementary function will be given by C3e raised to the power py plus C4e raised to the power minus py. So the solution will be given by here the solution will be equal to C1 cos px plus C2 sin px plus into C3 e raised to the power py C4 e raised to the power minus py. Please mind the correction, ध्यान दीजिएगा इस पर. तो we have obtained the value of u since we have assumed u is equal to x into y. So we got here u is equal to c1 cos px plus c2 sin px into c3 e raised to the power py plus c4 e raised to the power minus py. Okay, this is our third solution corresponding to negative constant. Okay, so we have obtained three solutions. The first one is corresponding to k is equal to 0. The second one is for positive constant, and the third one is for negative constant. Out of these three solutions, we have to choose that solution which is consistent with the physical nature of the problem. Physical nature of the problem, for example, here we are dealing with the heat flow. We are dealing with the heat flow in the metal plate in 2 dimension. Okay. Next, and the given boundary condition means boundary condition, we may have some condition on the boundaries of the plates. According to these conditions, what we have to do, we will find the value of these arbitrary constant present in the solution. So, which solution should I take will depend on the physical nature of the problem and the given boundary condition. We can understand this fact by taking an example. Okay, see. In this example, we have a rectangular plate with insulated surface which is 8 cm wide and so long compared to its width that it may be taken as infinite in length. So let us draw the plate here. This is our plate, and I am keeping it on XY plane. Now if I am taking width along the x-axis and width is 8 cm, then one edge of the plate can be taken at x equal to 0 and other edge can be taken at x equal to 8. Now since the length of the plate is infinite, so one edge can be taken at y is equal to 0 and other edge will lie in infinity, somewhere in infinity. Y is equal to infinity. Here y will tends to infinity. So other edge will be somewhere in infinity. Okay. Now look at the next line. If the temperature along the edge y is equal to 0 is given by, means along y is equal to 0, we have temperature is equal to 100 sin pi x upon 8. Look at the next line. While the other three edges are kept at 0 degree centigrade, means all other edges have 0 degree temperature. U is equal to 0. U is equal to 0 here, and also at infinity we will have 0 temperature. We will have zero temperature. Okay. So the next line is find the steady state temperature distribution U at any point. We have to find steady state temperature distribution at any position of the plate. So let's start the solution of the problem. The first step. See the first step. First of all, read the problem. We have a rectangular plate. Insulated surface means its surface is insulated, means heat will flow only along the x-axis or y-axis. No heat will flow along the perpendicular direction. And we have to find steady state temperature distribution. See, by our previous discussions, we know that the temperature distribution in the plate in steady state is given by Laplace equation. Okay, so first step is just write the equation by which we can find the temperature distribution in the plate. So temperature distribution in the plate in steady state will be given by Laplace equation. Second step, see, second step, what we have to do, we have to find the solution of this equation. I have already obtained the all possible solution of this equation, and you know we have these three solution for different value of k. This one was for k is equal to 0, this one was for k is equal to p square, and this one was for k is equal to minus p square. Okay, now what is our next step? Next step, you can see here various arbitrary constant. We can find the value of these arbitrary constant by applying the given conditions in the problem. So the next step is just to write the boundary condition by reading the problem carefully. See, from this figure, I am drawing the figure again. Here this age was at x equal to 0, x equal to 8, y equal to 0, and this one is lying somewhere in infinity, and along y is equal to 0 we have temperature 100 sine pi x upon 8, and all other ages are at 0 degree temperature. See, these are the boundary condition. We have these boundary condition 1, 2, 3, 4 because the conditions are given on the boundary of the plate. So these are known as boundary condition. So by this figure you can easily understand that we have 4 boundary condition. At x equal to 0 we have 0 temperature for any value of y. At x equal to 8 we have 0 temperature for any value of y, and when y tends to infinity then u tends to 0, temperature is tending to 0 for any value of x, and for y is equal to 0 we have temperature 100 sine pi x upon 8. So these are the boundary condition for the given problem, and by applying these conditions we can find the value of arbitrary constant. But one thing which is very important to note here is the sequence in which we are going to apply these conditions to find the constant. See, if we are not taking a correct sequence of taking these condition, then we would not be able to find the value of arbitrary constant easily. So it is very important to take a correct sequence of the conditions, है ना? Okay, so see what we will do, we will take the condition in which we have maximum number of 0 at first number, and following this rule we should take this condition at first number, we should take this condition at second number, we should take this condition at third number, and we should take this condition at fourth number. What we are doing, we are following the rule that we should take the condition at first number which has maximum number of 0. So this condition has maximum number of zeros, so I am taking it at first number, and this one at second number, this one at third number, and I will take this condition at last. So I am following the order first, second, third, fourth here. Okay, so this sequence is very important, otherwise you would not able to find the value of constant easily. Okay, so please keep it in mind. Now what we are going to do, by applying this condition, I am going to find the value of these arbitrary constant one by one. So here I am taking the first solution. The first solution was u is equal to c1x plus c2 into c3y plus c4. Now we will find the value of these constant by applying the condition. See, I am going to apply first condition, means we have to put u is equal to 0 and x equal to 0 in, say it is our first equation. We will put u is equal to 0 and x equal to 0 in this equation. Then we will obtain u is equal to 0, c2, since x equal to 0, so we will obtain c2 into c3y plus c4. Okay, now see, we have product of two number equal to 0, which means at least one of them should be 0 or both of them equal to 0. See, we have c2 is equal to 0 or c3y plus c4 equal to 0. But please note, we cannot take c3y plus c4 is equal to 0. Why? See, this factor is in product in the solution. If we take c3y plus c4 equal to 0, then it will create a 0 solution. है ना? So we cannot take this factor as 0. So what we can have? We can have c2 is equal to 0. So we will take c2 is equal to 0, as we cannot take c3y plus c4 equal to 0. So just put the value of c2 in the solution. So put c2 is equal to 0 in first. So we have u is equal to c1x into c3y plus c4. This is our new solution. This is our new solution. Say second one. Okay, now again, now we have new solution. We will do further calculation on this solution only. No need of the first one. This is our updated solution. Okay, now apply the second condition. Means we have to put u is equal to 0 and x equal to 8 in the solution in second. We will put this condition in second. So what will we obtain? U is equal to 0 and x equal to 8. So we have 0 is equal to c1 into 8 into c3y plus c4. Again, the product of these number is equal to 0. So one of them must be 0. See, 8 cannot be equal to 0. So c1 can be 0, and we have noted that c3y plus c4 cannot be equal to 0 because it will create a 0 solution. So what we have? c1 is equal to 0. But still, if we take c1 is equal to 0, then see the new solution. U is equal to, put c1 is equal to 0 in the second one. It will also give us a 0 solution. Means in total, we cannot take this one as a solution of our given problem. So we cannot take this temperature function for the given problem. So let us see what about the second solution. The second solution is u is equal to c1 e raised to the power px plus c2 e raised to the power px into c3 cos py plus c4 sin py. Let us find the constants of this solution one by one. First of all, I am going to mark it as first. Okay. Now apply the first condition. According to first condition, we have to put u is equal to 0 and x equal to 0. So put u is equal to 0 and x equal to 0. What we have? We have 0 is equal to, since x equal to 0, e raised to the power 0 is equal to 0, e raised to the power 0 is equal to 1. See, e raised to the power 0 is equal to 1. We know it very well. So e raised to the power is equal to 1. We will have c1 plus c2 into c3 cos py plus c4 sin py. Okay. Now since the product of two factor is equal to 0, any one of them can be equal to 0. Maybe c1 plus c2 is equal to 0 or c3 cos py plus c4 sin py is equal to 0. But see, we cannot take this factor is equal to 0. Why? Because this factor is in product and it will create a 0 solution if I am taking it is equal to 0. So we cannot take it as equal to 0. What will we take? c1 plus c2 is equal to 0. Now see, if we take c1 plus c2 is equal to 0, then it will give us c2 is equal to minus c1, as c1 plus c2 is equal to 0. So we can find the value of any one constant. So I have obtained the value of C2. So C2 is equal to minus C1. Now what I can do here, just put the value of C2 in the first solution. See, I have a new solution here. U will be equal to, I can take C1 in common, as here we put C2 is equal to minus C1. So we can take C1 in common, then U will be equal to C1 e raised to the power px minus e raised to the power minus px into C3 cos py plus C4 sin py. This is a new solution. And one thing more I can do here, let's see it later on. I am marking it as second. Okay. Now what we can do now, apply second condition, and according to second condition, U is equal to 0 and x equal to 8. At x equal to 8 we have 0 temperature, so we will apply x equal to 8 and U is equal to 0 on the second solution. So put it in second. आपको इसे second में put करना है. So just put it in second solution. We will obtain C1 e raised to the power 8p because x is equal to 8 into C3 cos py plus C4 sin py. See, here we have three numbers in product and the product is equal to 0. So anyone can be equal to 0. C1 can be equal to 0. E raised to the power 8p minus e raised to the power minus 8p is equal to 0. It can be 0 or this factor can be 0. See, we cannot take this factor is equal to 0. We cannot take C1 is equal to 0. If we take C1 is equal to 0, then C1 is in product in our solution. So it will create a 0 solution. Similarly, we cannot take this factor is equal to 0 because again it is in product, and if we take this factor is equal to 0, it will create a 0 solution. So what we can take, we have only one option. We can take e raised to the power 8p minus e raised to the power minus 8p is equal to 0. But see, we will have e raised to the power 8p is equal to e raised to the power minus 8p from this equation, and this equality will hold only for p is equal to 0. Since we know that e raised to the power 0 is equal to 1, so this equality will hold only for p is equal to 0, which is not our current case. See, this solution was obtained for the positive value of p square, not for 0 value. For 0 value, what solution was there? C1x plus C2 into C3y plus C4. So we cannot take this solution for our given problem according to the given boundary condition. Okay. So we cannot take the first solution, we cannot take the second solution. Now see what about the third solution. This is our third solution. Third solution is u is equal to C1 cos px plus C2 sin px, C3 e raised to the power py plus C4 e raised to the power minus py. We have this solution corresponding to negative value of the constant k. K is equal to minus p square. Now here again I am going to find the value of arbitrary constant one by applying the condition. So just apply the first condition. At age x equal to 0, we have 0 temperature. So just put u is equal to 0, x equal to 0 in one. Say I am taking it as first equation or solution. We will put it in first. So we will have 0, u is equal to 0 and x equal to 0. See, cos 0 is equal to 1 and sin 0 is equal to 0. So we will have 0 is equal to C1 into C3 e raised to the power py plus C4 e raised to the power minus py. Again we have two factor in product and this product is equal to 0. So anyone can be 0. We may have C1 is equal to 0 or C3 cos py plus C4 sin py is equal to 0. Now see, again we cannot take this factor is equal to 0. See, one more correction is here. C1 will be equal to 0 or C3 e raised to the power py plus C4 e raised to the power minus py is equal to 0. Please mind this correction. C3 e raised to the power py plus C4 e raised to the power minus py will be 0. This is a typo error. So we will have C1 is equal to 0 or C3 e raised to the power py plus C4 e raised to the power minus py is equal to 0. But we cannot take this factor is equal to 0. Why? Because this factor is in multiplication. If we take this factor is equal to 0, then this will create a 0 solution. So what will we do? We will take C1 is equal to 0. And if we take C1 is equal to 0, then just put it in, put C1 is equal to 0 in the first solution. We will obtain a new solution here. This is our new solution. U is equal to C2 sin px into C3 e raised to the power py plus C4 e raised to the power minus py. Okay, C1 is equal to 0. We will have C2 sin px, C3 e raised to the power py plus C4 e raised to the power minus py. Now, this is our second solution, new solution. We will do next calculation on the second solution. We have no need of the first one. Next, what will we do? Apply second condition, and second condition is at x equal to 8, again temperature is 0. So, just put u is equal to 0 and x equal to 8. We will have this equation. See, C2 sin 8p into C3 e raised to the power py plus C4 e raised to the power minus py. Here again we have three numbers in product, and anyone so can be 0 as the product is equal to 0. So here we will have C2 is equal to, this is C2 is equal to 0, or sin 8p is equal to 0, or C3 e raised to the power py plus C4 e raised to the power minus py is equal to 0. Done. Ab see, we cannot take C2 is equal to 0. We cannot take this factor is equal to 0. Why? Because these two are in product in the solution. These two terms are present in the product in the solution, and so if we take C2 is equal to 0 or C3 e raised to the power py plus C4 e raised to the power minus py is equal to 0, then this will give us a 0 solution. So what will we do? We will take sin 8p is equal to 0, and see, we can solve this equation for p, but this is a trigonometric equation, so in right hand side also we should have some trigonometric function, and we know that sin n pi is 0 for all value of integer. Here n belongs to integer, then we know that sin n pi is 0 for integer value of n. So we can write 0 is equal to sin n pi. Now just by direct comparison we can obtain the value of p. P will be equal to n pi upon 8. Done. So we have obtained here the value of p also. Now what will be our next calculation? We have obtained the value of p, so just put this value of p in the our second solution, this one. Just put p here. So here we have p is equal to n pi upon 8, n pi upon 8, n pi upon 8, and this will be our new solution. This will our new solution, and I should mark it as third. As third one also. Okay, now what will we do? Apply third condition. Up we are going to apply third condition on the third solution, and see what is our third condition. Third condition was temperature will tends to 0 when y tends to infinity. Means when y is tending to infinity, then you should be 0 there. You should tend to 0 there. Okay. See, here I am applying the limit y tends to infinity on this solution. Now see what will happen here. If we put y is equal to infinity in this term, then we know that e raised to the power minus infinity is equal to 0. E raised to the power minus infinity is 0. So this is satisfying our condition that when y tends to infinity, then you should be 0. But see this term. If we put y is equal to infinity here, then we have e raised to the power plus infinity. We all know that e raised to the power infinity is infinity. but this is not satisfying our condition that when y is tending to infinity, then you should be 0 there. It is making the term infinity. So if we can remove this term, then we can satisfy this condition. How can we remove this term? We can remove this term by taking C3 is equal to 0. Okay, I hope you got this point. To satisfy the condition y tends to infinity, u should be 0. We have to remove this term, and to remove this term, I am going to take C3 is equal to 0. So this condition will be satisfied only when C3 is equal to 0. So we have C3 is equal to 0. We have to take C3 is equal to 0 to satisfy the third condition. Now just put C3 is equal to 0 in the third solution. Okay, then we will obtain a new solution. U is equal to C2 sin n pi upon 8x into C4 e raised to the power minus n pi upon 8 into y. This will be our new solution. And here one thing more we can do. We can multiply C2 into C4 and we can write it as a new constant A. Why? Because constant into constant is a new constant. So we can write U is equal to A into sin n pi upon 8x into e raised to the power n pi 8 upon y. Okay, so this is our new solution. And next thing which we can note here, we are going to write a general solution. See how and why? Here you can see A is an arbitrary constant. Since A is an arbitrary constant, so you can take any value for A, and see for different value of A you will obtain different solution. And we all know that summation of all these solution will again a solution of the partial differential equation. Okay, so we can take a general solution by taking the sum of all the possible solutions. So I am writing A as an and take the summation where n is running from 1 to infinity. This will be our general solution which will contain each and every possible solution of the differential equation. Now I am marking it as our fourth solution. This is our fourth solution and the general solution which will keep each and every possible solution of the equation. So finally we have our fourth solution, and now what to do? We will apply our last condition. We will apply our fourth condition on the fourth solution. The fourth condition was u is equal to 0. Here just make one correction. U is equal to 0. Sorry, it is correct. Y is equal to 0. See, at y is equal to 0, we have a temperature u is equal to 100 sin pi x upon 8. So just put this condition in the fourth. हम इसे fourth में put करेंगे and what will we obtain? See, u is equal to 100 sin pi x upon 8 and y is equal to 0. E raised to the power 0 will be equal to 1. So we will obtain 100 sin pi x upon 8 is equal to this summation in which e raised to the power 0 is equal to 1. Okay, now from this equation we are going to find the value of this arbitrary constant. How? We can find, see, in left hand side and right hand side we have same mathematical function. So we can find the value of this constant by just comparing the left hand side and right hand side. We will compare the like terms of the left hand side and right hand side to obtain the value of constant, because both sides contain same mathematical function. So see, we can expand the sum here. If you can expand the sum here, then comparison will be easy. The expansion will give us a1 sin pi x upon 8. Next term will be a2 sin 2 pi x upon 8 x plus and so on. Okay, now what we have to do? We have to compare the like term, and if we are going to compare the like term, then we will obtain, see, sin pi x upon 8, and here we also have sin pi x upon 8, and the comparison will give us a1 is equal to 100. But what about the other term? We don't have other terms in the right hand side. which implies that all other constant will be equal to 0, as we can write the left side as plus 0 plus 0. So by comparison we can see that all other constant will be 0. Only one constant will be non-zero, which is a1. a1 will be 100 and all other constant will be 0. Now look at the next step. What we have to do, just put the value of all constant. All constant means a1 is equal to 100, a2 will be equal to 0, a3 will be equal to 0, and so on. So just put all the constant in the fourth solution. In the fourth solution we will obtain only one term will left. U will be equal to 100 sine n pi x upon 8x into e raised to the power minus n pi upon 8y. We will be left with the only one term. Here just put n is equal to 1, a1 sine pi x upon 8 into e raised to the power minus pi y upon 8, and value of a1 is 100 and all other constant are 0. So we will obtain the solution as u is equal to 100 sine n pi x upon 8 into e raised to the power minus n pi upon 8 into y. So this is our solution of the given problem. I hope you got it, and now I hope you can solve this problem by yourself. So thank you for watching this video. This is all about the Laplace equation or heat equation in 2 dimension in steady state. Thank you.